good evening. I'm Mohammad Al Haikal bin Hasbullah from Group 3. We'll be presenting about Experiment 3, application of first and second law. So Group 3 consists of myself, Al Hafiz, Afan, and RC. So next slide. So I'll be explaining about the abstract. So next slide again. The purpose of the experiment is to actually use the first law of thermodynamics and the concept of the second law of thermodynamics. The first law says that energy cannot be created or destroyed, where energy can only be changed or transformed into another form. On the other hand, second law says that energy is more likely to flow spontaneously from an area with higher energy level to lower energy level. So for this experiment, cold water will be poured carefully into a big container that contains a small beaker. So the initial weight for both of the water is actually taken. After that, the temperature for both water are recorded with 1 minute intervals until they have the same temperature. So based on the first law, the theoretical value for the change in energy for the whole system should be equal to 0. However, there is a value from the experiment, which means there is heat transferred to the surroundings. So next slide. So the objective of the experiment is to actually just to apply the first and second law of thermodynamics. Next slide again. So introduction about this thing. So first law of thermodynamics, also known as the principle of conservation of energy, says that energy cannot be created or destroyed. Energy can only be changed to another form. For instance, light bulbs changes electrical energy into light energy. So about the second law of thermodynamics is about the quality of energy and actual process that occurs in the direction of decreasing quality of energy. This is because energy flows randomly from a high energy level to a lower energy level. For this example, we can see that heat from a hot area will move to a colder area.
Okay, my name is Muhammad Arsi, and I will explain about the theory. Theory, as we all know, the first law of thermodynamics, that also known as energy balance. It is a fundamental calculation of heat transfer, which is E in minus E out equal to total E system. U system equal to 0 and U system equal to U hot water plus U cold water equal to 0. Another equation is MCP T2 minus T1 hot water plus MCP T2 minus T1 cold water equal to 1, which M equal to mass, Cp is a heat capacity in kJ, kilogram K Kelvin, and T is a temperature in Kelvin. Based on Clausius statement, it is possible for the heat to flow from the hot to cold reservoir without any work required. That means it can be easily transferred from hot to the cool reservoir. Okay, next, methodology. Methodology is really simple. For the first one is the water was heated in kettle, and then an empty small beaker was weighed. After that, the hot water filled into the small beaker, and the weight of the hot water recorded. The small beaker filled with hot water, moved then and then placed into the big container. Next. Okay, and then the cool water filled into the big container. Make sure the cool water not filled in the hot water. Separate them because it will be disturb the temperature. And next, the cool water filled until it reached the same level as the hot water, and the weight of cool water was recorded. And then, thermometer was set at both cool and hot water. For the final step, reading of both water was recorded for every minute using a stopwatch until it reached a same temperature, which is what we call thermal equilibrium. Okay, I will pass to the presenter.
So, I I am Muhammad Al-Hafiz. I'm going to proceed the presentation with the apparatus. So these are the apparatus that we use in this experiment, which are kettle, small beaker, stopwatch, balance, big container, and thermometer. Next, for the results, the data given in this experiment is the heat capacity of water CP, which is equal to 4.187 kg over kgk, and mass of hot water use and mass of cold water use M, which is 0.1980 and 0.8352 kg respectively. So the data given in this experiment also time T in minute, temperature of hot water T in degree Celsius, and temperature of cold water T in degree Celsius. So the time given is 0 until 26 minutes. So we need to calculate the temperature of change of hot water and temperature change of cold water. So these are the results. So we need to do the graph of temperature, hot and cold water against time. As we can see here, the temperature of water is decreasing while the temperature of cold water increasing. But at some point, the temperature of cold water increasing and decreasing. So this is the calculation that we need to do. Just like what RC said before, E system is equals to E in minus E out, and U system is equals to U cold plus U hot water. So the total of these two energy changes, M hot mass of hot water times heat capacity times delta T of hot water plus mass of cold water times heat capacity and delta T of cold water, which is equals to 0. So since we are using the same fluid for the heat capacity, so we just take 4.187 kg over kgk as the heat capacity. So energy changes for hot water, we got the value is negative 34.819 kg, while energy changes for cold water is 27.976 kg. So we just do the summation of these two energy changes, and this is the result, which is negative 6.843 kg. That's all for me. I will pass the discussion part to the next presenter.
Alright, so thank you, Hafiz. My name is Muhammad Afan bin Zubidi. I will continue the presentation with discussion and conclusion. The discussion, the graph shows the variation of hot water and cold water with time. The graph for the red color represent for the hot water, and the gray color shows the cold water. From the graph of hot water, it can be observed that the temperature is decreased with time, while for the cold water, the gradient is positive, and it means that the temperature increase over time. So what we can conclude here, thus this was obey the first law of thermodynamics law, which is energy is transferred from one form to another form. So in this experiment also, not all of heat from the medium is being transferred to cold medium. This is due to some of the heat might be lost to surrounding as the experiment is conducted in open system. We also found that the direction of heat transfer from hot water to cold water is higher than the direction from cold to hot water, higher than the direction from cold to hot water. The temperature of hot water decreased and the temperature of cold water increased, and this demonstrates the second law of thermodynamics, which it is described about the energy is transferred from high temperature to low temperature. At a certain time, we can see that the temperature for both hot and cold water is constant, no changes, and it might be error occur during was corrected. So here I was listed error that might be occur. The first maybe due to parallax error, taking the reading of temperature from thermometer of hot water during experiment might cause the change in mass of hot water, and the heat is not distributed equally to the entire system because of lag steering process, and the electronics balance is very sensitive. Thus, the data obtained when calculating the weight of water cannot be accurate due to the wind disruption. Next slide. Okay, so how we need to overcome the error just now. I was list 4 method also. So how the way to overcome the parallax error, maybe we can make sure the eyes must be perpendicular to the scale of thermometer. So from that way, I think we can overcome from the parallax error. Second is ensure the temperature is in range of 80 to 90 degrees Celsius to make sure the vaporization can be avoided. Do the steering process during reading the temperature for both cold and hot water so that the heat will transfer equally. Switch off the fan during conduct the experiment to overcome the wind disturbance and mass of water, and then mass of water recorded. So as for the conclusion, from this experiment we considered it is success. This experiment was proven that the first and second law of thermodynamics is valid because it's obey the first law of thermodynamics, where the first law of thermodynamics state that heat is transferred from hot medium to cold medium, and the energy cannot be destroyed and cannot be created and destroyed actually. While for the second law of thermodynamics state that the heat is transferred from high to low temperature and to higher energy level to lower energy level. The data obtained from experiment might be different with the actual value due to some error that I was explained just now. Hence, the overall conclusion, the objective of this experiment was achieved, which is apply the concept of first and second law of thermodynamics in various process. So I think that's all from our group. Thank you.